Alright guys, welcome to this page of the notes, and what we've done is we've just spent some time talking about medians, and more importantly the centroid theorem, which gives you a ratio of the lengths of the medians, the distance, the length of the entire median versus the distance from the vertex to the centroid. Alright, we just spent some time talking about what that ratio is. Let's see how it actually applies in a problem. What I've done is I've given you this nice little diagram right here where I have drawn those medians, right? How do you know they're medians? Well, please notice that the lines extend from a vertex to the median of the opposite side, to the midpoint of the opposite side, and I know it's a midpoint because it splits the opposite side into two congruent segments. Same thing here, C to point E. How do I know it's a median? Well, it goes from the vertex and splits the opposite side into two congruent segments. Yes, you'll need to be able to recognize that because I don't necessarily tell you that they're medians. I do mention that you're looking for a centroid, which should be a clue that you've been given medians, but I don't say anything about being given medians here. You'll need to be able to recognize, hey, these must be medians. They're extending from a vertex and they're splitting the opposite side into two congruent segments. It's got to be a median. Now, the information given. Well, AF is 9 units long. So let me do that one in green right here. This entire length right there, A to F, is 9 units. A to F is 9 units long. 9 units. Let's see, what else do I give you? Oh, C to E, right here. So this entire length right there, C to E. Sorry, that is not on my line. Hang on a second, I can fix it. C to E, let's see if I can do better. I can do better. C to E. What did I tell you? 7.2 units long. Okay, what do I ask you to find? I want you to use the centroid theorem, there we go, use the centroid theorem to find the measure of each length. What are those lengths? Well, here we go. I want you to find the length of AG. Okay, great, here we go. I want to know what is the distance from A to G. Now, the entire thing I told you was 9. I want to know what is the distance from the vertex A to the centroid, right? I know it's a centroid because these are all medians. So from the vertex to the centroid, and remember what our theorem said. Our theorem said the centroid is 2/3 of the distance of the entire median. So here's what we've got. I know that AG is equal to 2/3 the entire thing, AF. AG is going to be 2/3 of the distance of AF. Here we go. Remember, the way that we did this up above, we just write, I need thirds. I need thirds. So we're going to take 9, divide by 3. 9 divided by 3 is 3. So every 3 units is going to be 1/3. So let's split this guy up. 1, 2, 3, 1, 2, 3, 1, 2, Now, here, I'll need to extend this guy just a little bit to make them all congruent. Right about there, looks good. A to F. Okay, so I need to go, right? Formula says you need to go 2/3 of the distance. Well, 1/3 is going to be 3 units. I need to go 2/3. So 3 units is 1/3. 6 units would be 2/3. So 1, 2, 3, 4, 5, 6. That means that point G has to be right there at 6 units. So I already know AG has to be 6. But you don't want to have to draw this diagram every time. Please feel free to, but you don't want to have to do that every time. So let me show you how the formula works. AG is equal to 2/3 the distance from A to F. Well, A to F is 9, so you simply plug in a 9. Here we go. 9 times 2 is 18. That's going to be divided by 3. 18 divided by 3 is 6. And just like that, right, we get the exact same answer. Up here, drawing my diagram and dividing it into thirds, I wound up getting 6 units. Down here, using the formula, I wind up getting 6 units. So what is the distance from A to G? It's 6 units. Let's try another one. CE 7.2. Now, I'm not going to do all that 1/3 stuff up here because it's a decimal. Let's just use the formula. Here's what I know. I know that the distance, let's see here. I know the distance C, right? It's from the vertex to the centroid. Vertex to the centroid, so CG is 2/3 the entire length, C to E. Okay, let's go on. I know, I didn't ask you to find CG. I didn't. But this is where we have to start, right? This is where we need to start, so we'll start here. CG from the vertex to the centroid, right, is 2/3 of the way, C to E. I gotta go 2/3 of the distance of the entire length, C to E. So here we go. CG is equal to 2/3 of 7.2. Again, feel free to use a calculator. Don't fat finger something. You get 4.8. Please be careful. I did not ask you for the distance C to G. Not what I asked you for. I asked you for G to E. Now, if C to G is 2/3 the entire distance, which is 4.8, that means G to E is 1/3 of the distance, or essentially whatever's left, right? Since it's 4.8 from C to G, all you'll need to do is take 7.2, which is the entire distance, 7.2, and subtract 4.8. Here's what I've done. Here is G, and you now know that that distance right there is 4.8. I'm asking you to find this little piece right here. You know the entire thing is 7.2. You just found CG, it's 4.8. So how do you find the little chunk I asked you for? Segment addition postulate. All the way back to chapter 1. 7.2 minus 4.8. So GE is equal to 2.4. Now, for those of you that are really sharp, that are on top of this thing, you may have already recognized this. If CG, right, CG is 2/3 the entire distance, then that means that GE is 1/3. You could have simply set up this equation, GE is equal to 1/3. CE, right? If CG is 2/3, then GE would have to be 1/3. Plug and chug, you get the exact same thing. Either way, if you decide to use the formula the way it's written and find that distance, C to G, right, from the vertex to the centroid, and then just use the segment addition postulate, great. If that makes sense to you, I love it. But if it also makes sense to you, since this is 2/3, then the part I asked you to find must be 1/3, and you're comfortable setting up this equation, awesome, you'll get the exact same answer, all right? Which is great about algebra. There's generally more than one way to do these problems. As long as you do the algebra right, you'll get the same answer either way. Now, what I've done in this problem is essentially it's the exact same thing. We're going to use, right, the centroid theorem, but I didn't draw the triangle for you, right? And you got to draw your own triangle. So here we go, STU. So STU. All right, here we go. I want P to be the centroid of STU. We're going to let SW be a median of STU. So SW W, so we're going to have this guy right here. I need to go to about the midpoint, which let's say was right there. So there's one of my medians. That's W, and I now know that, right, those guys have to be congruent because W will be a midpoint. That's definition of a median, vertex to the median. So I got that one, median of SDU. If SW is 18, all right, so I know that that is 18. SW is 18. Okay, let's keep going. I want you to find SP and PW. Okay, great. So my centroid is somewhere probably right around in there. Right, okay, so I want you to find the distance from S to the centroid, and then I also ask you to find the distance from the centroid to point W. Well, again, remember the way that this works. I know the distance from the vertex to the centroid. I know that SP is 2/3 the entire distance. Right? That is the ratio for all medians. SP is 2/3 the entire distance. Well, I already know what the entire distance is. I know the entire length is 18. Plug and chug. Don't fat finger something in your calculator. And I wind up with 12. So I know that SP is 12. This distance right here has to be 12. How do I find the rest of it? Well, you've got two options. You can either set up PW then is 1/3 the entire length, SW. You could certainly do that. Plug in an 18, don't fat finger something on your calculator, and get the answer. Or you can do the segment addition. You know the entire length is 18 units. You know this little bit is 12, so all you have to do is find this last little bit right here, which would be 18 minus 12. Either way, I'm sure you guys can do that in your head. You wind up with 6. 18 minus 12 would be 6, or 18 divided by 3 is 6. Either way, you get the exact same answer, and so I know that this guy right here is 6. All right, guys, thank you so much for joining me for this page of the notes where we went through a couple of example problems based on medians and the centroid. On the next page of the notes, we're going to go ahead and take a look at the intersection of altitudes and their point of concurrency, which is known as the orthocenter, and I'll meet you there on that page.